electrical or electric potential due to a point charge. So we are interested in finding the electrical potential, say this is V, P. This is for a charge Q at some point P, that is why we have written V and in bracket P, which is at R distance from it. So what we'll do, we'll put this origin of, or we'll make a coordinate axis, this at 0, 0, 0. This is the position of this charge. This OP from this point to this point is R. This is the direction vector or the distance vector. So according to the definition of electrical potential, we know that this Vp is nothing but from infinite, we are bringing from infinite distance to this point P, and this is work done against. So this is what? Potential. So Vp is given by infinite to this point P minus, because work is done against the electric field, and this is E dot dr. We can also write in another form, right? We can change P and infinity here. We can change the limits. So this minus sign will vanish. So we can write P to infinity E dot dr. We know this. And what is E? What is electric field at this point? This is, we know that electric field due to a point charge or due to a point charge is kq by r square, and this r cap, unit vector along this direction. So we can write E here like this, or we'll put it here. We'll put it here. Let us put it here. Now this becomes P to infinity kq by r square rr and dr. Rr will, of course, because they are same vectors, so they will get vanished. Unit vector into unit vector in the same direction. It will be r cos 0, and this is unit vector, so 1 1 cos 0 is 1. So r and r will vanish. Then this kq by r square dr will remain, and this is what? This is from P to infinity. Now we want to find for this r, if you say, then this becomes r from infinity, and this remains same, everything remains same, right? So we can take this kq outside. This is r to infinity 1 by r square dr. Let us integrate 1 by r square. This is minus 1 by r. Let us put the limit infinity and r. So it will be 1 by r and 1 by infinity. 1 by infinity will become 1 or 0. 1 by infinity is 0. So only 1 by r will remain. So kq by r will be the Vp or V or the potential. So Vp is given by K is what? 1 by 4 pi epsilon naught. So 1 by 4 pi epsilon naught for K. This becomes 1 by 4 pi epsilon naught Q by R. And this is true for any charge. It may be positive, it may be negative. The potential due to a positive charge is positive, and because of negative charge, it will be negative. Q has to be put with negative sign in this equation if it is negative. Now from this shows that this V, the electric potential, decreases with respect to R, or it is inversely proportional to the R distance or distance vector. In case of potential, also the superposition principle we can apply, and in order to find the electric potential due to many point charges, this is only one point charge, we can do what? We can find the potential due to every charge according to this equation, and we can add them algebraically. A point P is 20 meter away from a 2 microcoulomb point charge and 40 meter away from a 4 microcoulomb point charge. We have to find electric potential at P. First, let us find the electric potential. As we said that if a point P is, say, 20 meter away from 2 microcoulomb, say this is 20 meter away, this one, and 40 meter away from, say, 4 microcoulomb point charge, right? So this is 4 microcoulomb, and this is 40. So this is 20 and this is 40. So how can we find the electric potential? Because of this, and we add them. So this is kq1 by r1 and kq2 by r2. Why we have taken? Because both are positive, so we can take the positive charge. KQ1 by R1, KQ2 by R2. K you can take outside. Q1 is given as 2 microcoulomb and micro is 10 to the power minus 6. So we change it to coulomb. This is 10 to the power minus 6. Other is 4 microcoulomb. Distance R, this R1 is 20 for this, and for 40 meter, because it is meter. So we just multiply it with K. K we know this is 9 into 10 to the power 9. So it becomes 1800 volt. So what is the work done required to be done in bringing the point to charge from infinite distance to the point P? This is simply this Vp into the charge, 0.2 coulomb multiplied, Vp into this V, this is potential, electric potential, multiply it with this charge, 0.2, so multiply 360, and find the work done work required to be done to bring 0.4 C, 0.4 coulomb charge from infinite distance to P. What we'll do, as we multiplied 0.2, we have to multiply minus 0.4 with 1800, means this Vp, so we get this joule. So this is how we get the work done or work required.